Alright, so we're asked to find the integral of sine x cosine x dx. So the first thing that we have to look for is what process do we want to use, and the easiest thing in my opinion is to use u substitution. You can use different processes, but I think this is the easiest. And the question becomes, well, what do we want to substitute? And do we want to substitute sine x or cosine x? Well, when we substitute sine x, we would have to find the derivative of sine x, and that would give us cosine x. And as you can see, we have a cosine x here, so that would mean that it would cancel out with this cosine x, so it's perfect. So we can say that sine x is equal to u, and then the derivative of sine x is, like we said, cosine x. So dx is equal to du, and then we have to put dx on its own, so we would say this is du over cosine x. And now what we can do with this is, well, we can say that sine x is our u, so we'd say the integral of u. Cosine x we did not do anything with, so we have to keep it. And then our dx, well, our dx is du over cosine x. And let's simplify this a little bit further, and we can say that there's an implied 1 here, so this is 1 over cosine x times du. So let's use that over here. Times 1 over cosine x times du. And what this would mean is that the cosine x canceled, and you are simply left with u du, right? And this is much easier to work with. Obviously, the integral of u du is simply, if this will work with me, is simply u squared over 2. And we're going to have to plug in our u. So that would be our u. What was our u? Our u over here was sine x. So let's plug that in. So this is going to be sine x squared over 2. And don't forget to add the c at the end because you need a constant. That right there is your answer.